a developer, what's your happy path? What gives you joy? That little endorphin hit. Is it getting a test to pass? Is it merging a change? Is it closing a bug? Ooh, what happened there? Wrong button. Sorry, my bad. Have I done? I've broken it? Oh.
Did you merge the change?
I don't know what I did. I'm going to use the keyboard. Is it closing a bug? Shipping a release? Whoa. This is wild. That's what happens when you never use PowerPoint. Is it getting positive user feedback? I cannot drive this computer. There we go. Oh, God. I'm sorry. I think getting, that really threw me. I think at the end of the day, it's shipping regular releases that bring features to your users and reduce bugs, including security vulnerabilities. So what are some of the obstacles on that happy path? Accidentally shipping new bugs, including security vulnerabilities, along with those new features, changes that break your build. I'm talking about security vulnerabilities here today, so that's where I'm going to zoom in a little bit. In particular, vulnerabilities that are coming in from open source dependencies that you're using. Those dependencies can be added when you're implementing a new feature, when you upgrade an existing pinned, or if you haven't pinned dependency, a new version comes out. And most commonly, an existing dependency has a new vulnerability found in it. Now, Mark Twain once said, there are lies, damned lies, and statistics. Well, I can tell you no lies, I'm not a statistician. I'd wanted to tell a compelling data-driven story here but instead I'm going to give you the data points that I was going to use, and maybe you're a better statistician than me. So deps.dev is a really cool source of many open source insights. And I took a look at their per ecosystem dependency data in conjunction with OSV's vulnerability data for a few language ecosystems. And what I wanted to leave you with here was a story about how, depending on what language you're using and how many dependencies you're taking, you're going to run into vulnerabilities this often, and therefore you should be considering optimizing your vulnerability management processes because it's a good thing. The framework that we've been using for thinking about vulnerabilities that we announced in early 2021 is no, prevent, fix. And OSV's data and supporting tooling is helping in all three of these areas. OSV enables you as a developer to identify known third-party vulnerabilities that pose genuine risk to your application and its environment so that you can focus on remediation efforts on the vulnerabilities that matter and sustainably manage the vulnerabilities that do not affect you. So we've got a two-legged strategy for achieving that. We've got the data story, which is to be comprehensive, accurate, and timely. And then using that database to enable a tool suite that, together with local application-specific information, enables you to identify and prioritize known vulnerabilities affecting your software. This tooling gives you control over known vulnerabilities throughout the software development lifecycle to give you confidence that your software that you're shipping isn't going out the door with any surprises in it that are going to ruin your day. So why is this important? The whole point of vulnerability awareness is for remediation, and where possible, avoiding them in the first place. If there's gaps in the coverage, or you don't feel that you can depend on the data, then OSV can't be relied upon to achieve these objectives. Nobody likes an unnecessary fire drill because of a false positive. And in the same vein, there's nothing more discomforting than discovering a false negative after the fact. Unpleasant discoveries like these chip away at confidence in the foundations. And as everything is built on this data foundation, we're seeking to make OSV as confidence-inspiring as possible by providing a comprehensive, accurate, and timely database of known vulnerabilities. So in order to be comprehensive, the database needs to have the vulnerabilities for every open source ecosystem that you're likely to be using. Today, we've got good language coverage and a growing number of OS distributions. The final frontier of languages that we haven't had is C and C++ software, because there's no central repository of this software. So CVEs are the current source of vulnerabilities in this software, but they have many challenges. Often they are not originating from the maintainer of the software they're relating to, so there's misaligned incentives around accuracy and actionability of the information contained in them. CVEs, as referenced in the National Vulnerabilities Database, use CPE strings as the primary identifier, which doesn't always have a clean mapping back to the software that it refers to, and the version information may not be in a usable format. And given the highly distributed nature of such software, having literally hundreds of sources of information makes it much harder to maintain a high quality bar. And given the diversity of sources for software and vulnerability sources of truth, there are many nuanced challenges that come with representing software vulnerabilities at scale. Having a good C and C++ software vulnerability story in OSV.dev is one of the final pieces of the puzzle for a truly comprehensive open source vulnerability database. What does it mean to be accurate? We believe it means being able to precisely identify the canonical location of the source of the software and the version of the commit that fixes the vulnerability. These allow you to answer the basic question of, is the software I'm currently using at the version or commit that I'm using it at in scope for this vulnerability? Or better yet, the more simple question to be able to answer is, do I need to worry about this vulnerability today? So here's a worked example of a Go vulnerability from earlier this year. Let's compare and contrast the level of actionable information that you get from a CVE record and the same OSV record. First, let's take a look at the CVE record. I've zoomed in here on the affected field. In this particular case, we have a version number. We're saying that less than 2.9.9 is affected. And thanks to how Go records its dependencies, we can eyeball our go.mod or go.sum file and determine that we're using version 1.1.7. So based on this information, it sounds like we're impacted by this vulnerability, right? Let's just table that for a moment and take a look at the equivalent OSV record as well. Similar to the CVE record, we have an upper bound on the fixed version, but take a look at this other subtle difference that's evident from the ecosystem-specific package information available. So bold-faced it up there on the top yellow line. So you can see here, there's this little detail that wasn't immediately determinable from the CVE record. It seems that there's two different major versions of the software, so we may have gone and thought that our version 1.1.7 was vulnerable when it wasn't, because that little detail wasn't so obvious from the CVE record. So based on this information available from the OSV record, is this usage actually vulnerable? No, it's not using a version less than 2.9.9. Additionally, the Go ecosystem includes vulnerable symbol information in the affected ecosystem-specific field. This is a little cherry on top, making it possible to determine if the vulnerability is being actively exercised by the code using this vulnerable version of the dependency. Having vulnerable symbol information like this allows for more fine-grained reasoning about the real risk of a vulnerability, particularly if a fix is not available or perhaps feasible to apply. At a minimum, it can assist with the prioritization of remediating a vulnerability that is being actively exercised by your code over one that is not. Let's take a look at another vulnerability, this time one in MIT Kerberos, which is an example of some software written in C. In this case, there is no affected version information available in the CVE record. So unfortunately, this isn't actionable. Somewhat frustratingly, there is version information in the human-readable description of the CVE record, so it would have been straightforward to construct a usable affected field when authoring the CVE record. Here's a sneak preview of the OSV record that we're able to generate from the CVE record in the NVD. In this particular case, because there was a viable commit hash in the CVE record's references, we're able to infer a fixed commit hash. Here's an example of another CVE record's applicability statement as referenced in the NVD. In this case, because the related Git repository is using version tags, we're able to infer matching commit hashes by resolving those version tags to commits. So stay tuned for an upcoming announcement for when our first pass of these converted and enhanced CVE records from the NVD will be available in OSV.dev. So I hope you're able to see from these few examples, getting the data quality story right at scale is both challenging and really important. From some of the initiatives coming in this space include making it easier for downstream consumers of OSV.dev's data to provide direct feedback to the source of that data, schema enforcement and programmatic data validation at import time, and machine-readable feedback from import time record validation. So once a vulnerability has been publicly disclosed, information about it needs to be available to potentially impacted consumers of the software it relates to, and as quickly as possible. Let's take a quick look at the record publication process for a few ecosystems. We'll take a look at PyPy, Go, NPM, and Maven, and I feel bad for not doing Rust now. For vulnerabilities affecting PyPy, the Python Packaging Advisory database is a GitHub repository with automated initial conversion from CVEs in the NVD. With awareness of package versions in PyPy, this is implemented with advisories from the GitHub advisory database and the new malicious package reports. Go has a well-defined process for their own vulnerability database, which is human curated by the Go security team. And they're the folks adding that symbol information I showed before. NPM is reliant on the GitHub advisory database and is supplemented with the new malicious package reports findings as well. Maven is reliant on the GitHub advisory database. If you've got an open source project in an existing supported ecosystem and you'd like to publish a vulnerability record in the OSV format and get them ingested into OSV.dev, your easiest path today is to use the GitHub advisory database. If you're not in one of these existing ecosystems, please talk to us and we'll help you get started. So OSV.dev is dependent on the timeliness of its upstream data providers for record creation and maintenance. Once a record is available, or an update is made to it, it's in OSV.dev and accessible by the OSV API within 15 minutes, 99.5% of the time. That's the SLO we're targeting. So, we're a small, scrappy team working on a hard problem, given the scale that we're operating at. Today, we've been focusing on the biggest bright spots, but this leaves many opportunities yet to be explored, like making it easier to generate OSV records as a side effect of making a fixing commit, making it easier for new data sources to onboard with OSV.dev in the first place, and looking beyond Git to also supporting commit ranges in Mercurial. We've got a good data foundation and we're working to make it stronger in a scalable way. Unfortunately, OSV.dev is all open source and your contributions are very welcome. Having data is lovely, but having accessible and useful data is so much better. The thing I love the most about OSV is it's got a really direct line to Google's company mission of making the world's information accessible and useful. So to this end, OSV.dev has a basic REST API for querying the database by package version or by commit hash. And this unlocks all sorts of possibilities. Client-side tooling helps with shifting left in the software development lifecycle, preventing vulnerable software from unintentionally shipping in the first place. So OSV Scanner is the rapidly evolving first-party tool for OSV's API. It has good support for scanning the log files of OSV.dev's currently supported software ecosystems. This enables time of change checks on these log files to find known vulnerabilities in new dependencies added, known vulnerabilities in the upgraded existing dependencies, and newly detected vulnerabilities in existing dependencies. It can be used to do this automatically as a pre-commit hook, a GitHub action, or you can just run it on demand. Here's a, too small to read, but it's attached to the presentation schedule. Demonstration of OSV Scanner being used for vulnerabilities in a locally cloned Git repository. In this case, it's a code base that is using NPM. So it's just a install of OSV Scanner as a Go package, cloning the repo locally, and then pointing OSV Scanner at it. Here's another demonstration. This time, same story. The repo that's being used happens to have two different languages in it, and when you run OSV Scanner recursively, it detects all the different log files, and it only found vulnerabilities in the Go ecosystem in this case. Finally, here's a very basic demonstration of OSV Scanner scanning a Docker container image. Today, only scanning for vulnerabilities in Debian packages detected in a Debian-based image is supported, so this is a lot of room for improvement here. Because the OSV.dev API is freely available, a number of third-party integrations have popped up as well, and here's three that I thought I'd mention. So you've got remediate. It's an open source tool by Mend. I saw their member now. For developers and DevOps that automatically creates pull requests for dependency updates. It can take vulnerability information into consideration when generating those pull requests, including from OSV.dev. It's particularly nice in that it works on more than GitHub, including GitLab and Bitbucket, so brings that capability beyond GitHub. Trivy is an existing popular open source security scanner. Dependency track, I think we talked about earlier today, from OWASP is SBOM scanning tool. So we're currently giving a lot of thought to the guided remediation story. We're mindful that when a developer initially starts doing vulnerability scanning, there's the potential for an overwhelming number of vulnerabilities to contend with. And some guidance on where to start is likely to be appreciated. There's a menu of choices available when it comes to remediating a dependency with a vulnerability in it. The appropriate choice or choices is going to depend on a number of factors, such as the severity or impact of the vulnerability, the context and how the vulnerable dependency is being used, the actual availability of a fix, the complexity associated with upgrading the vulnerable dependency. There's potentially quite significant cognitive load around what the remediation effort is going to entail. It's not just a matter of upgrading the dependency. It's quite possible that the upgrade has API breaking changes or other considerations, depending on how big a version jump we're talking about. It's all well and good to have checked in code that doesn't have any vulnerabilities reported in it, but it's also important to not have broken the application in the process of blindly upgrading dependencies and still be able to ship a new working release. And this is where we're well and truly off our happy path. And we believe that having helpful tooling for getting back on it will be appreciated. So OSV Scanner is working on this problem by adding interactive guided remediation functionality. We don't have anything that's really demonstration ready today, so I can only tell you about our vision and show you a mock-up. We're working on to have one tool and one workflow that you can follow, regardless of the language ecosystem or ecosystems in use. We understand that fixing all of your vulnerabilities in one go is not likely to be feasible. And we want to enable a variety of different approaches to selecting which vulnerabilities to care about first. You might like to start with the low-hanging fruit first and only remediate the vulnerabilities that don't involve a major Semver version change. You might like to only focus on vulnerabilities over a particular severity score. You might decide that vulnerabilities in packages past a particular depth in the dependency graph have a lower probability of actually being exploited. This mock-up, which is also hard to read, shows an example of what we'd like to offer developers. You'll be able to make an informed choice on which dependencies you choose to upgrade and know which vulnerabilities those upgrades will help eliminate. So you can manage the rate of change that you're introducing into your code base. Once you've got the initial potential fire hose of vulnerabilities under control, the next consideration is the continuous or steady state remediation of vulnerabilities as they crop up, either in existing dependencies or new or upgraded ones. These are all going to take you off your happy path, and the question is, how far left do you want to shift? Do you want the awareness of the vulnerability to be a commit preventing thing? Do you want it to be a build breaking thing? Do you want this to be a release halting thing? Each one has trade-offs to consider around timing, the relevance of what actions surface the vulnerability, and who is impacted by the discovery of it. There's not necessarily one right answer or a one-size-fits-all solution here. And fortunately, there's the flexibility to accommodate any or all of the above. This leads me to a really important consideration. I said at the beginning that vulnerabilities are just bugs. They're bugs that you may need to be fixing under time pressure. This requires you to introduce potentially breaking changes into your application's code and then ship a release. And you need ways to be able to do this quickly with a high degree of confidence. It's all well and good to just upgrade a dependency and make a source code vulnerability finding go away. But you have to balance this with not breaking your application or causing a ton of yak shaving to successfully make the upgrade and actually ship the release. This means all the usual code health and software engineering maturity considerations come into play, like test coverage, CI/CD, and release management practices. So today we've been focusing on the biggest bright spots. Next we'll be pursuing guided remediation, functionality in OSV Schema. More fully featured container image scanning, including image layer awareness, classifying vulnerabilities based on which layer they originate from, and awareness of what is a vulnerability from the image itself, the application code, and the runtime environment itself. And looking beyond GitHub to GitLab for OSV Scanner platform integration. If you can dream it, we can do it together. Please come and brainstorm with us at the OSV Scanner repository. I'd love to have a chat. So today we've been focusing on the biggest bright spots. Next, hang on, sorry, wrong. Right there. I hope that today's presentation has inspired you to think a little more about your own project's vulnerability management story and how using OSV might help you get back onto your own happy path faster and remain there more often. If you'd like to get in touch with us in the future, feel free to meet us via the OpenSSF Vulnerability Disclosures Working Group or the most appropriate GitHub repository. Thank you.